Alright, we would like to start today's lecture. Before we begin, I'll just show you what are the stuffs we're going to do today. So we're going to continue Onshape. Today's going to be the last day of doing Onshape. If you have any questions, please ask me anytime. Feel free to contact me if you have questions. We're going to create a new project, but here we're going to assemble different projects so that we can make an assembly of it. So we're going to draw aluminum profile. So the one title project is called aluminum profile. So you can see this sort of like aluminum profile. You can see you can order this online, but there are specifics to it. So we're going to follow the drawing of this. So out of these three perpendicular planes, we're going to choose the top plane, and then we're going to make sure the default length measure is millimeter, and then we're going to draw three construction lines. So because we have construction lines, we can use the mirror function. So once we have the function construction lines, we're going to draw something like this, and make sure you have everything without constraints, because if you have constraints, please, you're going to see the lines in black, and you're going to have a really hard time make sure they're properly formulated. You can see here there's a parallel constraint. So you can constrain these two, constrain these. Yep. You can make sure these are all constrained. And once you get the dimensions, you can see the color changes to black. So you can, this is all black. And then we're going to do the fillet. This is sketch fillet. This is not the bulk fillet that we used. So you can see the radius is 0.2. And then we're going to mirror this. And we're going to have another fillet at the end. And then we're going to mirror this again. So you see, we draw this basic sketch here, and then mirror once to this oblique line, and then we mirror the entire thing to y-axis. And then we're going to mirror this again. So it's really important to draw the first thing properly. And then we're going to create a new project called copper heater. This is one of the figures I used in my previous paper. So I'm just explaining this for the sake of everyone's knowledge. So you're going to draw a basic rectangle, you're going to extrude it, you're going to draw a new sketch on top of it. Of course, make sure the units are in millimeters, and then you're going to make this small rectangle on top of it, and then extrude it again, and sketch. These are the cartridge heaters, so sketch these. You can sketch, like anyway, but I recommend using linear pattern. So you're going to use the linear pattern, and then you're going to create another sketch on top of this, and yep. So on top of the small rectangle, you're going to draw a big rectangle and then extrude it. So it's going to look like there's a heater inside, and then you're going to remove the inner rectangle out of it. So yep. So you can see how it's removed. And then we're going to insert a preheater. So preheater is going to be inserted in this with this whole wizard. So we use the whole wizard. And here what you can see is we made so before we made construction line, but we have a construction plane here. So you can see this hypothetical plane right here. We should be able to create this, and then we can draw on top of this hypothetical plane. So we're going to draw this, and then make sure these are properly constrained. Again, this plane is hypothetical construction plane. So once you have this, you can draw a cross section of the preheater, and then you're going to do the sweep as we did in the last lecture. So you can make the sweep out of it. Notice how these are in two different colors because they're not connected and nor merged. We're going to make a manual stage, and so out of the base, we're going to draw a new sketch. and then we're gonna see how those are. These are the manipulators of the what was it? What's the name of this? A manual stage. So you're gonna draw these lines, of course. Select the radius and length properly, and then draw a new sketch and add new one. See how these are in different colors again. This one's blue. These are in gray. You're gonna add new sketch to it, and then make this rectangle fit right between the legs, and then create another sketch. And once you're done, you're gonna make a new document called pool boiling. This is one of the figures again I used in my paper. So in your new document, you can import previous documents, and then you're gonna generate new part studios. You can load all of them, and once you have one material, you can load a bunch of them, import it in one document. What I mean here is, once you draw this one aluminum profile, you can copy paste 4 of them in one document here. So you can make you can fasten them and then mate them. So what I use here is fastening, sort of attaching 2 surfaces with each other, and then once you're done with this, you did very well. So this is the entire thing, and then once you are up until this point, you can export this as pool boiling, and this is gonna be first. And the second one is Lego. You can do the Lego one first before the first pool boiling tutorial. So Lego tutorial comes with Lego block, of course. You can see these are the design specifications of the Lego block. And of course, we're going to start with choosing the right workspace units. And then we choose the top plane, of course. And then we draw a corner rectangle. And once we're done, you can see extrusion. Again, on top of it, we draw another sketch. And then draw these circles. Perfectly constrained. You can see it in black. And also, when you use linear pattern, make sure these this upward arrow is hidden somewhere on top of your screen. So copy 4 of them, and then you're gonna edit them, right? And then extrusion, and then you're gonna flip and then look from the bottom side of the design, and then you're going to draw a new sketch. So you're going to get rid of the inside. So you're going to get rid of the inside. Boom. You're going to draw all these, and then linear pattern, of course. These are small details that I missed. It doesn't really matter much. So for example, what I'm saying here is, this is the small, I don't know how to call this. This is a small support included in the object, but I forgot to make linear patterns out of this. So you can see this is supposed to be here as well, but I somehow canceled the wizard. Hope you can manage this. So once you have all of these whole supports at the end, you can get rid of some parts of it. Boom. Yes, this is how it's gonna be. So it can be assembled. Supposedly, this sort of match with each other. Supposedly, not sure. One thing important about this tutorial is that you're gonna carve your name out of it. So the case here is Lego, but please carve your name, so that later when I check your assignment, I can see your names on it. So here's the sketch function with text, and then with the text function, you can add this Korean as your font, and then you can minimize the size, and then of course extrude them. And then you can make a linear pattern out of this as usual. Yep, I think you extrude first and then use the feature pattern, and then you can export this. And wait, do we have everyone? 5, 4, 5, 14. Okay, I have a great news for you. I am really pleased to announce this grading plan. So our grading plan consists of 3 parts. Attendance, homework, and a team CAD project, but the CAD project is really, really simple. Homework is what you're gonna submit to PLMS. Please pay attention, this is really important. So you can go to the homework section of PLMS, and then you should be able to compress all the STL files and submit it. So again, you're gonna compress everything and then submit this on PLMS. And on top of that, we have a small teamwork, and this will account for 40%. But what's really, I want it to be really fair as possible. So you can see in the attached file, you're gonna draw like a whole geometry within your team, but then you're gonna mention which part you're assigned to. So if you go to the material, what we're gonna draw is nuclear power plant SMR. Wait, give me a sec. Boom, 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 boom. I think this is the one. Because we are all nuclear engineers, we have to draw something like this. As you probably know, NuScale SMR is the only SMR design that passed the NRC DC rule. So if you go to this website, you can see small modular reactor design out of this. And this is the NuScale design. You can see the 37 fuel assembly here. So it's 3, 5, 7, 7, 7, 5, 3. So that's why it's 37 fuel assembly. So this is how it's calculated. In each team, you're gonna have 4 roles, and of course, I'm gonna grade them appropriately. But the job of the team leader is to manage the entire thing. The team leader isn't really going to draw much, but there are 4 roles, so there are 4 people in each team. And in our class, we have 12 students plus 2 students who are just attending class for fun. So we're gonna create a team, and then we're gonna assign the design. Anyways, the way you're gonna do is you're gonna make individual part, and then the team leader will import the entire thing, share to the team leader, and then try to fasten them, make them, and then share the final project to me, including all the procedural files used in the document. Yep. So there are these amazing 12 students. If we go to team management, I thought this would be very proper. Again, this grading will be really, really fair. None of you will be affected by your teammates' performance except for the team leader. The team leader has to manage it properly because that's all the team leader does. And before we create this team, I want to explain the details of SMR nuclear power plant. The components of NPP SMR are as follows. There are 12 components to it. There are more components to it. If you read the final safety analysis report, you can see there are a lot of components relate to it. In the team, you would distribute the role freely as you wish, and then we have 2 more students, so the team leaders can decide based on rock, paper, scissors if they will include new person or not. So when we go to the nuclear power plant SMR, so the way it works is there's a reactor core, and it's gonna have all this fission reaction, and it's gonna heat up the water. So unlike previous PWR or BWR design, what happens in SMRs is the passive cooling. So we call them passive residual heat removal system. So on top of the control rod, there's an empty hull called riser, and the superheated water from reactor core will move upward within riser because of buoyancy. And then here is the downcomer, so it's gonna go down. Wrapping around the steam generator. The temperature of the reactor core, the water in the riser is usually 300 degrees, so it's enough to heat up the water and then create steam. And then once the steam generator creates the steam, and then it's gonna be forwarded to steam line, and then it's gonna be forwarded to like turbine, etc. So what you can see here is steam lines, feed water lines are here. Feed water line goes through the steam generator. So for the steam generator, it takes the feed water line and then creates the steam and then forward it to the next component. So these are connected. For a containment vessel, this is just the outline of it. So the team manager has to draw this very well. Also, the design specifications can be referred at NuScale final safety analysis report. And also for fuel assembly, this is really important. Again, there are 37 fuel assembly units here, and then each one has control rods. To reduce the workload of this project, effectively what's happening in this fuel assembly is there is 17 by 17 matrix within this fuel assembly, but we're not gonna do the 17 by 17 fuel assembly. We're gonna just lump it up into one piece of rod, fuel rod, and then here supposedly the steam generator has I think it was 690 helical coils, but we're gonna sum it up to 70. So again, the control rods are really simple. It's just rod, extrusion, tapered. Feed water line is also just pipes, right? It goes through some like complex geometry, but it's not as important. Riser is just an empty hull. You don't have to draw anything. Steam line is just pipes, so this one is an easy one. So with these 4 easy ones compiled in one roll will be equivalent to other rolls. Fuel assembly, what's really important is the 37 fuel assemblies, and then please make sure you have the right reactor core, and then neutron reflector is just a stainless steel shell. So it's going to be a cylinder with a small cylinder removed inside. And please, of course, you have to make all of these. And once this is over, the team leader has to create the RPV, reactor pressure vessel. So it's going to look like this amazing component. And if there's anything missing, the team leader has to draw and fill out the components, or give it to other team member. Hope you can get it done properly. And also containment vessel, the team leader is also required to draw this. And for the detail sizes, So the entire containment vessel for this is 23 meter cylinder with 4.6 meter diameter, but we're gonna reduce to 1/10, so it's gonna be 46 centimeters and 2.3 meter cylinder. And the reactor pressure vessel, of course, we're gonna reduce to 1/10 of the size. And also helical coil, there will be 70 units of helical coil. This is 690, but you're gonna reduce to 70 because it's too much. Also, the diameter will be 15 centimeter, but reduced to 1/10, so it's gonna be 1.5 centimeters. And fuel assembly will be 20 by 20. Boom. This will be 20 by 20, and this is gonna be 2 meters. Wait, I think I'm wrong here. I think this has to be a meter or so that the control rod can be 1 meter. Does it match? I think there was a significant error here. Please manage the sizes as you wish. These are basic recommendations. You don't have to stick to these. I got these values from Final Safety Analysis Report. Again, there are other documents included in this tutorial. So you can see, for example, if you go to New Scale Power, presentation report, you can see how they created this. So this is equivalent to the height of the system, and they use meter and feet at the same time. I don't know why they do this, but yeah. If you're the team leader, you can manage the overall sizing of the aspect ratio or sizing of the material. Please, as the team leader, you're responsible for the whole team project management, etc. And yeah, these are basic ideas. This is what it's supposed to be, but so far we're gonna have these ready. Do we have all the control rods? Yep. Do you see these? So the control rods are inserted here, not these two, right? Because this is where the control rod is inserted. And yeah, please, if you're a team leader, please take care of this. So I would like to separate the team, if you wish, to give you a fair, fair assessment of the workload. I think if 2 persons really work hard, this can be done in 24 hours. If what it requires is hardworking 2 persons within the span of 24 hours, maybe faster, because there are other assemblies you can refer to. For example, here, if you go to this website, you can see other 3D models. There are other 3D printing, fuel assembly, etc. So you can refer to these designs, and you can get the brief idea of how these work. Anyways, so I hope this is all acceptable. And again, you're gonna be judged by the component that you submit. And the way you finally share the document to me is, so when you go to Onshape, sign in. When you go to Onshape as a team leader, you can share the document. For example, I don't know. Boom, share the document to, I don't know, someone else, and by typing their email, and then you should be able to share it to me. My email is included in the material. It's it's in PLMS. I think I was mistaken here. Boom. My email is here, so please share it with me. And the deadline is the end of November. And yeah, I'll be very generous and fair in the assessment. So feel free. This is not to give like too much burden or pressure to students. Just to try to like adjust a new environment and try to recreate what's already designed. Yep, and then you can check out FSAR, etc. Anyways, let's go to the team management. We have two more students. Oh wait, I think we can just include these two. Oh wait, never mind. Okay, we're gonna split this into 3 teams, and then what was it? We're gonna try 5 attempts, and then we're gonna choose the last one as the final team assignment. Okay, so this is how it works. So this is supposed to be 1 team, but I'll give you. We'll try 4 more times. So this is the 2nd attempt, 3rd attempt, 4th attempt, and then we're gonna come up with the last attempt and then finalize it as the team. And then again, you don't really have to blame the teammate. It's the job of the team leader, and the team leader is gonna be assessed based on the entirety of the project. Let's go. Okay, so this will be the team, and the first row will be the team leader. Or if you want to transfer the what was it? If you want to transfer the role, you can share it with others. For example, if you don't want to do the role of team leader, you can give it to, I don't know, someone else, and then exchange the roles freely. I'll upload this to our material. But anyways, so please, can you please stand up? We have 2 more students, and they're basically taking this class for fun. So if you win the rock, paper, scissors, you can take 1 more person each. Clear? 가위바위보 한번 하시죠.
안 내려지는 거
이게 한 번 더. 네, 그러면 any other questions? I hope it's all clear. I really thought of distributing this role really carefully, because otherwise there will be 1 free rider and then it's gonna mess up the team. So I didn't want that. Certainly, if you have questions, please try to implement as far as you can, because this is also confidential data in some sense. They don't explicitly share all the design components of the new scale SMR. So you're gonna have to imagine some of the components and then size them appropriately. Anyways, so once you're done with this, you're gonna have to share all the part studios to me, including everything. So not just the assembly, but also the documents that are loaded by the assembly. So the 3 teams will share me 12 components plus 1 assembly. So there'll be 13 components, 13 documents to me. So I'm gonna be shared with 40 documents at the end of the semester. Also, when you look at this project report at the end of the semester, you're gonna be really, really proud of yourself. Please pat yourself on the back. The team leader is supposed to submit this report, and you're gonna write the name of the components and who did this part, so that I can assess them properly. If you have any comments, if there's any declaration of competing interests, please let me know. I hope there isn't. Yes, if you have questions, please ask me, and then we can move on to the beginning of the material.